Hey everyone, welcome back. Today's day 3 of my 30-day FAANG grind. I'm solving 6 to 10 LeetCode problems daily, breaking each down on video and sharing with all of you on YouTube. I'm Divya, by the way. I interned at Massachusetts Institute of Technology, where my area of focus was on machine learning and statistics. Currently, I rank globally on top 0.3% on LeetCode, and like most of you, I'm also preparing for FAANG interviews. Yesterday, we tackled two pointers, and today we are jumping into prefix and suffix based problems, which is super common in arrays and strings and a favorite theme in FANG interviews. We will also sneak in a few sliding window prefacers to keep all those patterns sharp. Before I begin, if this video helps you, please give it a like, share with your friends, and please hit that subscribe button so we all can prepare for interviews together. Let us go. So problem for today is LeetCode 53 maximum subarray. And before I talk about the problem, let us look at the constraint. And it is there, okay. So the problem asks us, hey, we have been given an array and we have to find the maximum sum of the subarray. And we have to return that. Sounds cool and simple, right? Let us move to the dashboard and we'll try to investigate it and find an optimal solution for this problem. All right, I'm on the dashboard. Now, before I begin, what will be the brute force approach for this problem? What we have been given? We have been given an array nums and we have to return the maximum sum of the subarray. So the brute force should be pretty simple, right? It should be that we generate all the subarrays, compute their sum, and return the maximum sum of all the subarrays that we have, right? Now, what will be the optimal approach? Before I delve you into the optimal approach, there are two cases that we need to consider. Let me take you through those two cases, case one and case two. What do we see? Before I begin, let me just tell you what these abbreviations mean. MS means maximum sum and CS means current sum. Okay, current sum means the current sum at current state of index you are standing at. Okay, and similarly, maximum sum is the maximum sum till that index. Now, what are we doing over these two cases? We are trying to track how those two variables are moving. In the first case, we see every time current sum is encountering a positive number, its magnitude is increasing. And along with current sum, maximum sum is also moving upwards. Okay. For example, from here to current sum began from zero, right? It encountered a positive number and it came over here of a higher magnitude state, right? And hypothetically speaking, if magnitude of maximum sum was somewhere lesser than that point, so maximum sum would have also been updated and would be at this peak with current sum, right? Now, what if current sum at the next index finds a negative value? The value of current sum, it will go down, but maximum sum, it will remain as it is. What if current sum then encounters again a positive value? The current sum value will jump and so will the value of maximum sum. If current sum encounters a negative value, it will fall down, but the maximum sum will remain as it is. If current sum it encounters a positive value once again, it will jump or shoot up, and so will the maximum value. Right? This is how current sum and the maximum sum are moving. Now, what about case two? In case two, I've intentionally taken all the values to be negative, one after another. More often than not, for example, current sum began with zero, right? At zero, it encountered a negative value, so it fell down. Again, current sum encountered a little bit of positive value, so it rose. Again, a negative value, it failed, it rose, it failed, rose, and fell again. Okay. So what do we see? We see that current sum is monotonically, in some sense, it is decreasing. Okay, it is decreasing, right? Current sum value is decreasing, and maximum sum will never pair up with current sum in this state. And maximum sum, it might either remain zero or whatever the minimum or whatever the maximum value of all those minimum values are. All right. Now, so this was how current sum and maximum sum is moving. Okay. How do we solve this problem then? Our objective will be to move across each and every index in the array, and at each state, we can compute the current sum and try to compare it with the current maximum sum. And we update the maximum sum accordingly, okay? But at any state, our value of current sum If it plunges down to 0, we will reset the value of current sum and we will not try to carry it forward. Why? Let me give you an example. As you can see over here, we have three different columns. First is the current sum column, second is the value at the next index, and third is the result column. What do we see first? We see what if at the current state our current sum value is 0 and we encounter a value of 100. We see the result will remain unaffected at 100. What if we encounter a positive value? The current sum, the next value is 100. The current sum will jump to 107. But what if our current sum is -1 and we encounter 100? The value will fall down to 99, right? Which is lower than these two, correct? Why did it fall down? It fell down because upon encountering current sum as -1, we did not reset it, which we must have done, okay? And had we reset this -1 to 0, it would have transformed itself into the first case, 0, 100, and it would have killed me 100. So the objective is that every time current sum plunges down to 0, we should reset its value as is shown in these three cases so that our current sum must yield something positive afterwards if it is encountering a positive number. Otherwise, if current sum is negative, no matter how less negative it will degrade the next value, which we don't want, as it is degrading in this case to 99, right? Minus 0 is always better than negative, okay? Because it will not affect the next value magnitude, okay? Let me quickly walk you through this example pretty quick. So I'm at index 0 and current sum it is -2, maximum sum will remain -2, and we see that current sum, since it is negative, I will reset it back to 0. Now at this point current sum will increase to 1, and is 1, what is a larger, which is larger than 1 and -2? It is 1, correct? So maximum sum it will be updated to 1. It is -3 now, so current sum it will become -2, and since -2, which is larger, -2 or 1? Obviously plus 1. And since it is negative, so it will reset to 0. We are at this index now, so it will transform to 4, which is greater. 4 or 1? 4 is greater, so update maximum sum to 4. We come over here, it becomes 3, which is greater. 3 or 4? 4 is greater, so we do not touch that. It comes over here, it becomes 5, which is greater. 5 or 4? 5 is greater, so we update 4 to 5. It comes over here, 5 becomes 6, and which is greater, 5 or 6? 6 is greater, so we update 5 to 6. It comes over here, 6 becomes minus, 6 becomes not minus, 6 becomes 1, right? 6 becomes 1, which is greater, 1 or 6? Obviously 6 is greater. It comes over here, it becomes 5, which is greater, 6 is greater, right? So since we have exhausted, because we are out of the array now, we can return 6 over here. And this is the simple code. Initially current sum is 0, as you can see in these two cases. We also declare maximum sum and we assign it to the first value of the array. You can assign it any arbitrary value, but that value must present in the array, must be present in the array, okay? Then we make a scan across the entire element of the array. And in the first line, we are adding the next value to the current sum. Then we are making a comparison over here between maximum sum and the current sum that we have accumulated. And if at any point our current sum value plunges down to 0, we reset current sum to 0. And once we have exhausted the loop, we return maximum sum. So the time complexity of this thing will be as it is determined by this thing. It is linearly bounded within order of n, and time space complexity will be order of constant because we are just using two constant variable, correct? So that was all there was to this problem. I hope you understood, especially how current sum and maximum sum are moving when they're encountering positive number, and how they're getting affected when they're encountering negative number one after another, and what are the importance of these three cases, and what happens if our current sum plunges down to 0, and why we should make a reset of current sum to 0 when that happens, okay? So yeah, that was all there was to this problem. Let us go to the LeetCode dashboard and we'll try to submit this problem. I've already solved this problem, so I'll just copy and paste my code. Let me do that. That is the code. Let me run it. And as you can see, the test cases has been accepted. I hope you understood this problem. If you have any doubts, please let me know in the comments. I will see you in the next video.